Today we are going to start the new chapter. The name of the chapter is Gravitation. So first we will start with the historical introduction. So what is that? The motion of the celestial bodies such as the moon, earth and the planets has been studied for or has been a subject of great interest for a long time. And the famous Indian mathematician and astronomer Aryabhatta also studies about these matters, and in the year in 5th century AD, and he also wrote a book on this particular topic, and he also established that the earth revolves about its own axis and moves in a circular orbit about the sun, and that the moon also moves in a circular orbit about the earth. He told that around thousand years ago. So after 1,000 years, after Aryabhatta, the Tycho Brahe, I write the name. First name of the scientist was Aryabhatta. And next one is Tycho Brahe. After 1,000 years of Aryabhatta, so in the year 1546 to 1601, and Kepler in the year 1571 to 1630. So they also studied about this matter, and they studied about this matter, and Kepler also formulated his important finding in the 3 laws of planetary motions. So the Kepler's law of planetary motions we will study afterwards. But in year 1665, in the year 1665, it was very fruitful for Isaac Newton. So what happened? And he was only 23 years old in that time, and he was forced to take rest in his home because the Cambridge, he was a student of Cambridge College in that time, and the Cambridge College was closed due to the plague pandemic. Now you are experiencing the corona pandemic, and that time it was the plague pandemic, and it was also same type of disease, and he was the college, everything was closed, and he was forced to stay in his home. And that time, in this year, he performed brilliant theoretical and experimental tasks, mainly in the field of mechanics and optics. In the same year, he focused his attention on the motion of the moon about the earth. So already it was known that this is the earth here, and the moon is also revolving around the earth in this way. So the moon is also rotating in a circular path. So already you know that when something is rotating in a circular path, then some force is working towards the center, and that is known as the centripetal force. So he started thinking about this one. So what type of force is that it is working towards the center? And if the force is there, and there might be, definitely there is an acceleration. So this is the first question came to Newton's mind, that what is that type of force? What force is helping to rotate the moon around the sun? And with that thinking, Newton was sitting under a apple tree when an apple fell down from the tree on the earth, and this sparked the idea that the earth attracts all bodies towards its center. So Newton got the idea that earth attracts all the bodies towards the center of the earth. And next thing is that next question after that he understood and he tried to formulate it that one to find out the amount of force, which force the earth is attracting towards that. So with that Newton's gave the law of universal law of gravitation. So I'm going to write that one, universal law of gravitation. So what is this? What is this law? The gravitational force of attraction between any two particles is directly proportional to the product of the masses of the particle and is inversely proportional to the square of distance between the particle. The direction of force is along the line joining the two particles. So this is the law. So it is the law, the gravitational force of attraction between any two particles is directly proportional to the product of the masses. So if I take two particles here, this is the two particles here, this is M1 and M2. So what he said, that these two particles are attracting each other. This is F force and this is also F force. The same force both will attract. That means when the apple was falling to the ground was also attracted by the apple. They want to say that I will explain why the ground was not or why the earth was not going to the apple. Why the earth is only the apple is going to the earth, that I will explain you later. But thing is that earth is also attracting a force as the earth is attracting a force on apple, and apple is also attracting a force on the earth, because the law is telling like that. So the two masses M1 and M2, and the distance between these two masses is R. So you can write F is directly proportional to M1 M2. First it is sent the product of the masses is given, and F is inversely proportional to the square of the distance. It is also given. Then and it is the inversely proportional to the square of the distance. When come inversely proportional, then you have to write 1 by like that, like this. So F, so you can write F is directly proportional to M1 M2 by R square. And if you want to change this proportional symbol into equal symbol, then you have to multiply it with a constant. Then you can write F is equal to, then we use a different color here, so the G. So G is called the constant, and this constant is known as universal constant of gravitation, g into m1 m2 by r square. Okay, and this g is known as g is equal to universal constant of gravitation. Okay, so these are all the overviews we studied today, and next class we'll learn about the value of the g, and also who invented or who find out the value of the g, that we will also learn, and also we develop some knowledge regarding the circular motions and also some kind of planetary motions and all. Okay, so today is up to this, so thank you very much.